Okay, so since you've all built your little models, we're going to look at the models a little bit at a time as we go through. Let's grab the piece of paper I put on your table, and let's start from scratch here. Why can't I see what I'm trying to do? All right, so we're looking at volumes by cross-sections, and so you each have a different cross-section that we'll look at. The first one is not even volume, though. It just says, consider a region R. So this is f of x, and this is my g of x. We want to find the area of the region, okay? And that's what we have been doing the last couple of days, right? I want to find the area of the region bounded by the curve, so I'm going to have to do what kind of process? An integral, right? And since this is the area that's bounded, my limits of integration, I'm going to go from -1 to 2. Everybody good with that? -1 to 2. Of, and then which one goes first? G of x, okay? So of x plus 1, and then do I add or subtract? Subtract, minus x squared minus 1, all of that dx. Okay? So this is just exactly what we've been doing. So let's simplify that up a little bit. That is the integral from -1 to 2 of negative x squared plus x plus 2. Do you all agree with that? X. Can we integrate now? Yes, so when I integrate this first term, that's going to become x cubed. It's still negative, and then I divide by that 3. Plus, this becomes x squared, and I divide by 2, plus 2x. Do I need a c here? No, because I'm going to evaluate between -1 and 2. So when you integrate, you either put plus c or you put that you're going to evaluate from something to something, right? Okay. So then when I evaluate, I substitute in my 2. That's going to give me 8, so I will get -8/3 plus 4/2. And here's 2 reasons I wouldn't put this as a 2. Okay, like we did on the last one, sometimes it just makes it easier to combine your fractions. Have you ever done something that simple and done it wrong just because you had a brain fart? Maybe you never have, but some people have. Like, just leave it. Like, if we're going to leave this as a safe stop, it's fine. And then that's going to be plus 4. Then minus, substitute in my -1. So -1 cubed is -1. Then it makes it negative, so that's just 1/3. -1 squared is 1 plus 1/2 plus, or actually I'll make that -2. This is a safe stop, okay? If it is a free response question and you don't have to do anything else with it, that is totally a safe stop. Just in the interest of time, I'll tell you that all simplifies down to 9/2. We good so far? Okay. So let's look at this next one. We'll starts talking about volumes. So we're going to consider a region R bounded below by the curve of f of x squared minus 1. So the same 2 curves, right? And I want to find the volume of the solid formed by square cross sections perpendicular to the x-axis. So here's my square that I'm going to put perpendicular to the x-axis. Looks like that. Who has the squares? Can you hold it up and let everybody admire your work of art so they can see what it looks like when you have cross sections of squares? Turn it sideways. Whoops. Turn it. So, woo. Okay. So there's your cross section. Yeah. Good job. There's your cross sections that are squares. Wow. Okay. So if you want to sketch this in, funny. So here's what kind of a three-dimensional square would look like popping up off your picture. You have to use some imagination, okay? I know. You just make it look a little slanted. It's supposed to be 3D. It's okay that you can't draw it. It's okay even if you can't always visualize exactly what it looks like. I wanted you to be able to visualize one. That's why we created these. But we'll be able to get there through that. So the idea is that we have an infinite amount of these squares, right? And if I want to find the volume, then I can find the volume by adding up all those little areas. Could you find the volume of this piece of paper? Okay, it has length, it has width. Does it have depth? Yes, or it wouldn't exist, right? Like, I mean, it's minute. I'd need a little caliper thing. I mean, it's very, very small. Could you more easily maybe find the volume of this stack of papers? Yes, but because one piece of paper has some volume to it, when I stack it up, I get more, right? And so instead of just finding one piece of paper, if I want the volume of this whole stack, if I knew the volume of one piece of paper, I could add up each little piece of paper, right? These are all the same, so I could multiply, but with your figures there, they're all different. But you need the area of each one of them, and then because it doesn't have any depth, you add them all up. It's just like when we're finding area, we're summing all those little rectangles up. We're summing all so the rectangles are like, we're still summing up rectangles and squares. We're just summing them up as the area. Does that make sense to you? We're good with that? Okay. So what I need to be able to do then, I lost my pen, is, then I'm going to have to write with my finger. That'd be really bad. All right. What I need to do is I need to be able to find the area of this square. Okay? So with the square, all four sides are the same, right? What is the formula for the area of a square? Yes. Or S squared. It's length times width, base times height, side squared. It's all the same thing. It's fine. So I need to find this length right here. How do I find that? The y's, right? So we had decided that this is f of x, this is g of x, right? So your s is equal to, that length right there is whatever the value of g of x is minus the value of f of x. We good with that? So that really is, your g of x was, oh wait, sorry. G of x is x plus 1 minus x squared minus 1. And that equals negative x squared plus x plus 2. Right? So what we're going to do to find the volume is we are going to integrate the area from -1 to 2, the area of each of those little squares. The side length is this. Area is equal to s squared. So I'm going to take this negative x squared plus x plus 2 and square it, dx. Everybody with me? Do we understand why we did what we did? Are we going to do the same thing when we get to the rectangle and when we get to the semicircle and when we get to the equilateral triangle? Not the exact same thing. Same concept, but this is going to look different because this is going to be different. You with me on that? We good? Okay, so in the interest of time, we could type this in our we could do it by hand, or we could type this in our calculator. You would get 8.1. I'm just going to tell you what the answer is. Okay. What's the question? Well, it's volume, so it would most likely be units cubed. But remember, when we're doing these, depending on, I mean, this is just straight up volume. It has no context. But in the contextual problems, sometimes those units could look different, even though it was volume or whatever. But yes, that would be units cubed because it was volume. That's a good question. We good? Okay. So next, we have the region, same functions. So we know that this is f of x, and we know that this is g of x. And we know we're going from -1 to 2. This time, it's the volume formed by rectangular cross sections with a height of 1. So here's our rectangle, right? So I know that the height is equal to 1. They told me that. If I want to draw it in over here, if I want to draw it in over here, it would look something like this. Yes? You just think of those like them sticking out of the board, right? This is a square, but remember we're thinking about it like three-dimensionally like this. So this length, which would be this right here, how am I going to find this? We'll call this the base. G of x minus f of x again. G of x minus f of x. And we already figured out what that is, right? That is negative x squared plus x plus 2. How do you find the area of a rectangle? Base times height, right? Okay, so I want the volume of the cross sections with rectangles with a height of 1. So for my volume, I'm going to integrate. I'm going from -1 to 2. Since I'm finding volume, I'm integrating area, right? So I'm integrating the area of the rectangle. I find the area of the rectangle by base times height. My base is negative x squared plus x plus 2 times the height, which is 1, dx. So what is that? Did we already find that somewhere? What is it? 9/2. Now, is it the exact same thing? No, but it gives you the same number. If there were units on here, because that was a very good units question, this would be units cubed. This one up here when we got 9/2, because it was area, this would be units squared. So they represent two different things, they just happen to be the same number. Okay, it's a coincidence type of thing. It'll do it for you. It'll do it itself. It kind of forces. And like, you don't even necessarily have to put the 1. We want to write the 1 as we're doing this though, because this could say the height of 3 or 5. Like they could change that. So I want you to think about it. Was my door open? Okay, perfect. Thank you. My door was shut off. Big time reader, Adrita. Congratulations. She got a pen. Y'all are just jealous because you didn't get a pen. Okay, I'm sorry. Lorenzo was over here. He's really wanting to show off his little work of art because I forgot to say it. Show us. Pick it up. Show us. Don't drop it. Nice. There are your rectangles. Okay, good job, good job. Hey, nerds are cool. You shut up. Hey, you got it. Good job. All right, so now we're doing the same region, same function. So this is f of x. This is g of x. We have equilateral triangle cross sections. Who's up next? Show us your beautiful triangle cross sections. Your dinosaur. Y'all look. Ooh, turn it so they can see the side. Ooh, ah. All right, good job, guys. All right, so here's the deal. So we've got this equilateral triangle, right? It's going to look something like that. It doesn't. Your picture does not have to be beautiful. You don't even necessarily have to draw it in, but I think it's helpful sometimes. So for your equilateral triangle, so even though it's sideways like that, I think we all feel better when the triangle looks a little bit like this. Would you agree? Okay, so they are going to help me through. How do we find the area of a triangle? Base times height, right? Okay, so how am I going to find the base of this triangle, which would be the same as this right here? G of x minus f of x. So I'm going to put, we're still going to call these s's, I guess we can, but that is going to be g of x minus f of x. Do we agree with that? Okay. But let's think about how we actually find the area of an equilateral triangle. So here's the height. I hate that I can't really do dotted lines here. Since it's an equilateral, what is the measure of each angle? It's, okay, so they're each 60 in here, which makes us little 30, 60, 90 triangles, right? So this is 30. So if I look at just that triangle, welcome back to geometry and pre-cal here. This is 60, boo, this is 30. Your rule is that this is S, this is 2S, and this is S times the square root of 3, okay? Maybe I shouldn't have put S's there because I don't want to confuse you because I'm using them two different ways. I'm going to erase those so I don't confuse you. You need to be able to find the area of an equilateral triangle if necessary, which is basically what we're doing. So if you can find it some other way, that's okay, but yeah, you kind of need, this is a need to know type of thing. So if I have that this is S, this is S times the square root of 3, right? So if I'm going to use x's for the side links over here instead. So if I said each one of these was x, this right here is half of x. Would you agree with that? Yeah. Okay. Which means this part, so if this is my s, then this right here, the height has to be 1/2 x times the square root of 3. So the square root of 3 over 2 times x. So the area of the triangle, when I put it in here, that's 1/2 times the base, which is x, times the height, which is the square root of 3 over 2 times x. I multiplied, because it's 1/2 x times the square root of 3. Because the whole side is x and I only took half of it. Does that make sense? Okay. So that means that your area is really, when I multiply these together, square root of 3 over 4 x squared. I multiplied it all together. This is actually something you should have done in geometry, so it's not like you've never seen this before ever. Ugh, boo-hoo. You would have done this before lockdown. Mm-hmm. This came long before lockdown. This is first semester. Don't even start. Yeah. I taught geometry forever. I know when this stuff is. It was long before lockdown. Okay. So now that I have that, we're going to integrate these areas, right? And we decided that the x is equal to, that's your side length, that's what this is, which we already found, which is negative x squared. I forgot what it is now. Plus x plus 2. So I'm going to integrate from -1 to 2. And this is my area right here. Square root of 3 over 4 times, now these two x's are different. Maybe I shouldn't have used x at all. I was reusing variables in it. So this, of whatever the side length is, and this is my side length right here. So this is negative x squared plus x plus 2 squared dx. That's your volume. And I'll just tell you, because we don't have time for calculators, that this is going to give me 3.507. Okay? We good? All right. So now we're going to look at the semicircles. Semicircle cross sections perpendicular to the x-axis. So show us your beautiful work of art without dropping it. Let everybody see your semicircles. Ooh, y'all aren't even looking at their semicircles. Ooh, ah, okay. All right, so I have a semicircle. How do you find the area of a circle? Pi r squared, 1/2 base times height. Pi r squared was right. No, I heard 1/2 base times height over there. Pi r squared, but it's only a semicircle, so it's actually 1/2 pi r squared. Do we agree with that? Okay. So when we draw in our semicircle over here, it looks like a D. You can't draw it. There you go. All right, but you have, even if you can't draw it, it's fine, but you have to be able to understand that what you have here is not the radius. What is it? Get off your freaking phone and answer my question.
Diameter.
It's the diameter. Welcome to 6th grade, boys and girls. Okay, it is the diameter. I want just the radius, right? How do I find the diameter? I would multiply the radius by 2, but this, I can find the length of the diameter. G of x minus f of x. Okay, so if I want the radius, that is half of g of x minus f of x. Do we agree with that? Yes? The diameter is this y minus this y, just like we've been doing it, but I only want half of it, right? Because we need the radius. Because, well, you don't want the diameter is what we actually have on there. What we want is the radius. Yeah, so that's why we take half of it, okay? Now, we know what g of x minus f of x is. That is negative x squared plus x plus 2. If we didn't know it, we'd have to go find it, right? So then when I put it in when I take the integral here, I'm going for volume, I'm going to integrate from -1 to 2. The area, and the area is 1/2 times pi times the radius. Look what the radius has another 1/2 in it, times negative x squared plus x plus 2. This part is squared because this whole thing is the radius, dx. So be careful with your parentheses and your squares. Like the calculator can do that for you, but you have to be able to set it up. And then I will tell you on this one also, this is 3.181. We'll look at some application and whatnot of this, and we'll do some more. But are we good? Okay, so we're going to leave. Don't take your thing apart. We're going to leave it. I'm going to put them back here. We'll look at them again tomorrow. Don't we want Sit Lolly to see this beautiful work of art?